Hello everyone, thank you very much for joining us today for our Maple 17 Training for Educators and Researchers webinar. So in today's webinar, I'm going to be basically just walking you through kind of a tour of our fundamental concepts of working with Maple. And this is going to include using Maple's Clickable Math interface to visualize and to solve some mathematical problems. I'm going to try to limit the amount of hard to understand code and commands. I'm going to still show you some code and commands, but I'm going to try to keep that to a minimum. I'm also going to show you some of our tools that we have available for education. And these include our math tutors and math apps. So to begin, let's just jump right in and talk a little bit about using Maple. And I'd like to start by talking a little bit about help. And this is kind of one of the first things that you look for when you start a new language or a new programming system is how to find help. So first and foremost is our help menu. So you just go up to the top here and go help, Maple help. And here you can search for various subjects. So let's search for, say, the diff command. So that'll bring up our differentiate help page. And so on. You can also browse our table of contents in order to view various areas inside of Maple. So we can break this down and look at mathematics, algebra, and so on. We can also call Maple's help system directly from within Maple. And we do this by using the question mark command. So if we type in question mark plot, this will bring us right to the plot help page within the Maple help system. A couple other resources I wanted to draw your attention to include under help, manuals, resources, and more, manuals. Here we have the user manual and the programming guide. Both are excellent resources. The user manual is a good resource if you're kind of starting off with Maple, you want to learn how to do the basics. And the advanced programming guide would be your next step after you've finished off reading the user manual and so on. Last but not least, and you'll hear me referring to this one quite a bit today, is our Maple portal. And this is really one of the best first places that you can send a new user in Maple. The Maple portal features a collection of demonstrations and tutorials for working within various areas and various subjects in Maple. And not only that, but we also have customized portals for engineers, students, as well as math educators that feature specialized content that help you to, say, create content for your classes within calculus, linear algebra, and so on. So I'll actually be using this quite a bit. I'll be talking about the Maple portal in several of our examples today. But now let's switch gears and actually start talking a little bit to Maple and seeing how it works when we're interacting with Maple. So first, if you want to just start by entering in some numbers into Maple, you just type in 7 minus 2, press enter, and have a result returned to you directly. Same thing if we want to work with squares, so 3 squared minus 9. You'll notice here that when I press the Shift 6 key to get the caret, the squared is actually put it as a superscript on the 3. And that's what we call our two-dimensional math interface. Same here if we type in 3 divided by 7 plus 4 over 5. Again, this appears to be what we call two-dimensional because it's giving you not just a single line input, something similar to what you see here, 7 minus 2, but you're getting the 3 over 7, the full input the same way that you would write it on a board, or if you were writing this out on a piece of paper, you're getting that same exact input and output in Maple. So let's talk a little bit about the actual output that you receive in Maple. So if we enter in a value in Maple, say here is 1, 2, 3, 4, 5 squared, the result is actually returned to you on the next line. So here's the input and here's the output. Now in document mode, which is the mode that we're working on right now, we can actually have the result returned to us on the same line. And we do this by pressing Control equals on our keyboard. So here are a couple of quick examples. So pressing Control equals, and this returns the result in line. Now one reason why this is really handy is that this lets you leverage the the power of Maple's document interface in order to insert both text and math together on one line. So now I've just gone to the front of a math area. I pressed F5 to switch between our text and math modes. And here you can see that when I'm in text mode, it's just like I'm typing into Word or something like that. When I go to math mode, it draws a little gray box around the area. Let me switch the equal sign here to an is. Now you can see I've actually composed a full sentence that mixes text and math directly inside of our session. Now we can grab this, and of course change the font size, and apply some different formatting as well. Now if you'd like, you can also suppress the output of Maple expressions by using the colon at the end of your command. So if I type in here 1 + 1 colon, this will actually suppress the output. And one reason why this is handy is later on I'll show you how to assign some variables. And if you just want to assign a variable, say x, to the value 1, you may not want that output repeated back to you because you already know the value. So moving on, here I've just put together a couple of quick examples on how we can work with mathematical expressions in Maple. And here you'll actually see that these are all, actually the first two here are equivalent notation. So we could either use the integrand symbol with sin x of dx, or we can use the int command inside of Maple, so int sin of x with respect to x, or we can use sin prime of x as the same as the diff command, diff sin x comma x, or d over dx of sin x. So these three here are equivalent, as well as these two. So there are multiple ways of entering the same value inside of Maple, and it really just comes down to which one you're more comfortable with or what your end goal is. So if you're putting this together to be used inside of a paper, then you might use text and math such as this. We'll do control equals to get them in the same line. Or if you're just doing some strict programming, if you're just working away in Maple and trying to find the answer for a derivative or an integral, then you could just use the int command itself. Now I'll show you how you can enter a few of these commands quickly and easily through our palettes. So up here on our left side, we have our collection of Maple palettes. I'm just going to expand our expression palette. And to begin with, I'm going to build this example here. So I'm going to insert the sum. I'm going to start, you'll notice here that it's highlighted in blue, so I can type in k there. And I'll press tab in order to move through this sum. And we'll go 0 and -1. And again, I'll move back over here and get e to the power of k. Pressing enter, the result is returned. Let's build another quick one. So we'll do a partial derivative with respect to x. So x, tab, and I'll grab the square root symbol, and we'll do x squared minus y squared. I mentioned before you can also assign variables to certain values inside of Maple. And we do this using the colon equals operator. So if I type in x colon equals 10, this will give the variable x the value 10. So we can observe this by either typing x into our session and have the value returned to us, or we can open up our variables palette up here, and this will show you any active variables in your session as well as their values. So this is pretty handy if we want to increment a value, say x is equal to x plus 5. So now we'll see that this value has been incremented by 5 in both areas here. Another way that we can interact with Maple is by using our context-sensitive menus. So say we wanted to assign this expression here to the name m. I can right-click on this input and then go to assign to a name. We'll call it m. So now you can see that if you use m later in your session, it'll return this exact expression. And this, again, you can view up here in our variables palette. If you're done using x, or if you're done using m and you want to reclaim that to use in a different operation, you can use the unassign command. So here we unassign x. You'll notice it disappears from our variables palette. So now if I try to go up here again and use x, it just returns the variable x. We can also unassign by right-clicking up here in our variables palette. Right-click, unassign, and now the value of m is just m. Now you may have noticed as we've been walking through our examples, there's been a number on the right-hand side that's been steadily increasing. And these are what we call equation labels. If you'd like to reference an equation label, you can press Ctrl-L on your keyboard, and then type in the respective equation label. So here I'll type in 15, and let's do an operation. Let's have 15 plus Ctrl-L, 16. In order to add the expressions or the output that are found on equation label or equation line 15 and 16. So let's move on and talk a little bit more about clickable math inside of Maple. And this is really where Maple shines, is in its ability to make interacting with math as easy as possible. So let's start here, and let's actually build this from scratch. So we'll do the integrand of x squared minus 1 with respect to x. So what we can first do is we can evaluate this. So I'll press Control equals to evaluate this in line. And then we'll grab this expression. We'll right-click on it, go to Plots, and perform a 2D plot. So that's a really quick way. I just right-clicked on the expression or the output and went to Plots, 2D plot in order to generate a plot. Now we can also right-click on plots. So if I go to right-click on the plot, I can then go down to, say, Probe Info and turn on the nearest datum. And this will let us walk through and examine the values that are found along this surface. So here you can see that was two quick examples on how I've used the context-sensitive menu. So that's the right-click menu in order to interact with math and plots. But now let's use what we call our smart pop-up technology. And this is a little bit of a longer example. Smart pop-ups, what they let you do is they let you take a sub-expression of your output. And if you hover on top of that, you're presented with several options. And these are what we call smart pop-ups. And what you can do with these is we can use them in order to step through a problem. So in this case, what I actually want to do is I want to step through this problem, and I want to solve, or I want to show that the left-hand side of this problem is equivalent to the right-hand side. So let's start here with trig identity, and we'll apply the angle reduction identity to start. All right, and let's step through again, hover over the highlighted sub-expression, and we'll see here that as I scroll through these, you'll notice that there's a little box that pops up on top that shows you which identity you're going to be applying. So again, I'll apply another identity. And another thing to note is that as I apply these identities, the actual operation is shown to you in line on the next line. So now I want to introduce you to drag to solve. So I'm going to grab this sub-expression here, and rather than using the smart pop-ups, I'm just going to grab this, I'm going to drag it over to the other side. And then I'm given a smart pop-up which previews the result of that, which is that we are adding it to both sides. And then let's grab this sin x and divide both sides by that. Now again, we'll grab another sub-expression, and in this case, I'm going to apply normal to it. Now I'll grab the 4, divide both sides by that, grab cos of a squared, and apply a final trig identity, the Pythagoras identity, in order to show that step by step, the left-hand side of this equation is equivalent to the right-hand side. So this is really a great tool if you want students to walk through a problem and to know how they got there all the way. This smart pop-up technology basically lets you follow that path and go from the beginning to the end of a problem, all just using your mouse and getting to that final result. So now let's move on and talk a little bit about entering matrices into Maple. I'm just going to quickly just close off our two palettes and just open up our matrix palette. So the first example I'm going to show you is just how to build a very quick 4x4 identity matrix. So if I, up here in the matrix palette, click on choose, I can drag out to 4x4, and we'll make this an identity matrix, and we'll just click insert matrix. Let's do another quick example. In this case, I'm actually going to go here and type in some values. So 5x5, and we'll make this one filled, and we'll make this an upper diagonal matrix. So lastly, let's build a 3-element column vector, 3 rows, 1 column, and just for fun, we'll fill it with random entries, and we'll insert that entry. Now, if you'd like to do some math with, or some operations with these matrices, you can do that as well. So in this last example, let me just go back here, and I'm just going to insert another 3x3 matrix right in front of the other column vector that we just created. Now, if I leave a space between these two, Maple will actually use that space as an implied multiplication. So this would be the same as using a Shift 8, a star symbol, or something like that. But just for elegance, I'll just leave a space and then press enter in order to perform this operation. Now the matrix browser is, or this matrix palette is, it's a good way to start if you want to make some very small, simple matrices. But if you want to really start making really big matrices and working away in your computations, you're probably going to want to know the matrix command. So the matrix command is capital M matrix, and then we give the dimensions of the matrix, so 2500 by 200, and usually this will be enough. So if we just have this is enough to create a very large matrix. If I double click on it, you can now browse this matrix using our matrix browser. But at the same time, if we want to make this a little bit more interesting, we could also, as a final argument of this matrix command, give it a generating function. So here we could put in 1 if we wanted to be filled with 1s, or 0 if we wanted to be filled with 0s. But more interestingly, I've also used, you can also use something such as a random number generator. So here I've used the random number generator to give us values between 1 and 10 to fill out this matrix. So again, if I double click on this summary matrix form, you can now view that this matrix has been filled with random entries between 1 and 10. And also, another nice thing you can do with the matrix browser is you can quickly and easily export this data set to an Excel XLS file. So you specify a file name here, sheet range, cell range, and so on. You can also browse an image of the matrix, just if you are interested in determining any specific patterns within your data set, and so on. So here comes a quick tip again. If you want to have another couple of really excellent examples on working with vectors and matrices in Maple, I would recommend viewing tutorial 5 in the Maple portal. So again, going back to our Maple portal, the 5th tutorial here is working with matrices. And if we open this up, here is just a quick sample of what this looks like. So I won't show that right now, but that's a kind of a homework assignment to go and have a look at that one. Now let's move on and talk a little bit about visualization in Maple. And I'm going to start with plotting in some examples for plotting in 2 dimensions. And a lot of these examples I'm going to utilize our context menus. So here I'm going to type in 6x minus x squared. And I can either right click on the input or the output, it doesn't really matter. So I'll just right click on the input and go to plots and generate a 2D plot. So there's our 2D plot of the surface. Now again, as we saw before, I can right click on the plot, turn on the probe info, and go to nearest datum in order to examine values on this line. We can also export this plot. So if I go right click, export, And here you'll now notice that there's a number of different file formats that we can directly export this plot to. So then if you want to turn around, you want to make this plot inside Maple, you can quickly and easily generate a PNG file that you can then use in your presentation or wherever you'd like. Let's show another quick example here. So sine squared of x, and I'm just going to enter in two values here, and sine of x over 2. So let's right click on the second entry here, go to plots, 2D plot, and here's quickly generated plot of this curve. But now inside of Maple, what we can also do is we can very quickly and easily superimpose another expression on top of an existing plot. So to do so, what I can do is I can highlight an expression, and press and hold Control on my keyboard, and then just drag it down. So now I've got both plots on one plot interface. So again, that was, I'll just delete this plot. I grab an expression, press Control on my keyboard, and drag it down. So now if we'd like, we can differentiate these lines a little bit further. So I'll just change the line width. And again, let's change this to a dashed line. And we'll change this line width to 4. And we'll change the line to a dash dot, and so on. Now, as I mentioned with our matrix command, you can also do a lot of really powerful plots using the underlying plot command. So these examples that I've shown you here have all just used the clickable math options. All these clickable math options underneath, they'll all use the plot command. So here I can use a plot command as well as specifying a list of plots. So it's a list in Maple because I've actually enclosed it inside of these square brackets, as you can see here. And what this is a list of Bessel J curves for certain values. My next option here is I'm specifying I want to show these values over the range x is equal to 0 to 10, as well as a final option called filled. What fill does is it fills the region between the curve and the x-axis. You notice it's somewhat transparent too, so the line that you're actually following here is a little bit darker than the transparency here. So that way you have a nice way of blending together several plots on one plot. So next, let's show an example using a three-dimensional plot, sine x times y. Where I click on the input, I go to plots, 3D plot, x and y. So there is our 3D plot of sine of x times y. And just by default, when I click on top of a three-dimensional plot, I can rotate this. Using our plot toolbar up here, we can also zoom in if you'd like, and pan around. Same as we saw with the two-dimensional plot, we can also right-click on 3D. And now there's a couple of different formats for exporting this three-dimensional plot to 3D file formats. Same as with plot, you can also create some pretty neat plots using the plot 3D command. So here's an example using plot 3D with a cylindrical coordinate system. And lastly, here's another quick example using the plot 3D command. Now, in order to learn how to actually build these plot commands, one of the great tools that we have at your disposal is our built-in interactive plot builder assistant. So if I click on some input, so here is x squared plus y squared, I can go to plots, and instead of just generating a plot, I'm going to go down to plot builder. So with the interactive plot builder, I can now specify values on how I'd like to change this plot. So let's make the x-axis from 10 to 10, and we'll do the same for the y. And we'll go into the options menu to further customize our plot. So we'll add a title, and a caption. Here we can also change the coloring systems, the axis values, and many other options. Before we move on, we can also preview this to make sure that we are in fact producing the plot we want to show. And if we're happy with this, we could just press plot, and that'll just return an image directly to our interface. But rather than doing that, what you can also do here is you can press command. What command will do is it'll return the actual full command that you would have to type into Maple in order to generate this surface. So I'll just copy this down to the next line. So here you can see we've actually used the plot builder to generate a plot command. And now that we actually know the full command, we can go on, we can change titles, we can modify the caption, we can remove that, we can change the y-axis values, all in line. And this is going to save you a lot of time because you won't have to go now and go through the plot builder and go through those 3 or 4 steps. You can actually just modify your plot 3D command call in order to make the plot that you're interested in seeing. So the plot builder can also be used to create animations. And let's create another animation, this one in 3 dimensions. So we'll do sine of A times the surface we had above, so x squared plus y squared. So we'll right click, plots, plot builder. Now rather than clicking and making a plot, we're going to now change this and make an animation. And I'll just leave this with the default values, but we can just preview this now. And then we'll just play this back in order to see how this varying the parameter A in sine of A changes this surface. So if we're happy with this, we can press plot. Otherwise, we can go back in and again return the command. So here's the full plot command. And grab this, drag this to the next line, and reproduce this over and over again. You'll now see that up here we are actually using the animation toolbar, and with the animation toolbar you can also control the frames per second, and the same as with 3D plots, we can pan and zoom and so on. So to show you another quick example here, and this one's going to use a couple of things I've shown you so far today. This is going to use our matrix command as well as plot 3D. So what I do here in this matrix command is I actually specify a matrix of coordinates. So here you can see there's 3 coordinates in each list here. And there's 4 points in our coordinate system. Using the plot 3D command as well as the viewpoint option allows us to plot a 3D surface as well as use a viewpoint to scroll in and view this surface. So again, let me just turn down the frames per second there and show you that again. I'm just going to modify this. I'm just going to turn off the axis. So here we go again. We are now zooming in using our matrix of coordinates on a plot 3D surface and rotating while we're moving. So that just gives you kind of a small glimpse of one of the potential applications and what you can do when you start combining our really powerful commands inside of Maple to create some really neat applications. Now, if you'd like to browse some more of our plots that you can use inside of Maple, I recommend going into our plotting guide. So if you type in !plotting guide into Maple, or if you just type in plotting guide into the Maple help system, this will give you the entire Maple plot guide. It'll show you every last plot that we have available for your disposal, and it's really a good place to go if you're, say, looking for a certain plot or you don't want to construct and do all the work yourself. We may already have a plot available for you that you can use on your particular data or your surface. So next, let's move on and talk a little bit about the specific tools that we have available for education. And to start, I'll just mention really quickly, in Maple 17, we've actually introduced a new package called Essay Tools Package. And this package is basically designed for linguistic analysis in the grading of essays. And to kind of give you an example of what it does, if you give it a set of essays that have already been graded by hand, or the computer can basically look for patterns in the essays to try to weight them according to given scores. What Maple can then do is use a Maple scoring model in order to pick from up to 20 different algorithms, each of which will measure dozens of properties of these essays in order to formulate a model that can be used to predict scores for new essays. So that's kind of on the educator level. Let's talk a little bit about what the students have available to them. And we'll start with the student packages. And Maple student packages are specifically designed for teaching and learning concepts in mathematics. So here you can see we have sub-packages in calculus, linear algebra, numerical analysis, and actually vector and pre-calc, and so on. Now each one of these is basically geared to be a very, very friendly and intuitive interface for students. And rather than just making the students use our more complex programming commands, the student sub-packages are designed for very, very quick and intuitive methods for entering and working with math inside of Maple. Within each one of these student packages, we also have several tutors available. So if we go up our Tools menu here, we can go Tutors. You'll notice here that there's a lot of overlap between our student package and what tutors are available. So to give you an idea of what some of these tutors look like, let me just open up the Integration Methods tutor. So I'll go to Tutors, Calculus Single Variable, Integration Methods. So this gives us a very elementary example to begin with. So we're given the function sine of x squared with respect to x. And what we want to do is we want to have a student step through this problem and basically on their own figure out what the solution of this would be. So this tutor is built in such a way that if they'd like, they can get a hint in order to try to determine what their next step should be. So the hint here is try rewriting sine of x squared. If they're unsure, they can click next step, and it'll then tell them, okay, the rewrite rule has been applied. And we can progress in this way if we'd like. So notice the plus in the expression, and now we can go down, we can apply any one of these rules, or we can click next step in order to move to the next step. So we can proceed through a problem step by step in this way. In order to have a student get a full understanding of how to step through a complex integration or differentiation problem. The handy part about the Integration Methods tutor is also that it returns all these steps to you in line, and a student can view these steps in order to completely understand how to work through a problem. So I'll close this one, and then when I close this, you'll actually notice that this has all been returned to me step by step with our starting expression and all of the different steps, as well as the rules that were applied all the way through this problem. So within Maple, we actually have, I think it's just over 50 different tutors available. And a couple of other really good ones we have available include the linear algebra Gauss-Jordan elimination tutor, which lets you step through row reducing a matrix, and so on. So there's a lot of really good examples there, and I would definitely recommend going through a number of them. But now let's switch gears a little bit and talk about ways that you as an educator can actually create some of these resources yourself. And with our explore command, you can actually create an interactive application, an interactive demonstration for a student using just one command call. So here I've entered in a little bit of math again, so I can right click on this, and just near the top of our menu we can see explore. Now what I want to do is I want to explore this surface using two parameters, a and b. So we're going to let explore vary the parameters a and b, but we'll keep x fixed. It's our variable for this problem, so we'll now go on and explore this. We'll insert this. And once explored, you'll actually be presented with a plot as well as two sliders. What the students can then do is drag out these two sliders in order to view how this mathematical expression changes as we vary the two parameters a and b. Now Explore becomes really powerful if we start using it to explore plots. So here I've entered in another plot using our plot command, so plot of cos of 8x times sine of bx. So again, I'll right click, explore, And now we're presented with exploring with respect to the parameters a and b. Explore, insert the rows. Now let's drag out these parameters in order to explore how this surface varies over these two parameters. Now if you'd like, if you were happy with this example, you could then just take this section of Maple code, save that in a worksheet and send it to a student, and they'd have an interactive problem that they can engage with and interact with. So showing you one more quick example, I'm going to make this, I'm going to actually make an example here using one line of code. So I'm going to use the explore command. And again, as we saw before, I'm going to use a plot command within Explorer. But here I'm also going to inline specify the parameter and initial values for these parameter sliders here. So now I'm just having to insert row, and you're presented with an interactive application that you can then send on to your students that using this initial values, you may actually want the system to be in a certain initial state that you can then turn and send out to all of your students and peers. So again, for more examples, this is one of those times where I refer back to our Maple portal. So if you view the Maple portal for educators, there's another good example here on using the exploration assistant. Now let's talk a little bit about task templates inside of Maple. And task templates are similar to what we've now seen with the Explore command in that they are kind of the pre-built boxed environment that you can use to create interactive demonstrations for students. So inside of Maple, we have over 300 different task templates. And these are all accessible through our Tools, Tasks, Browse menu. And here you can browse all our various tasks. So let's, for instance, look at calculus. And it's a little bit smaller so we can view everything on the screen here. So we'll go to calculus differential, and I want to show the applications and tangent line one. So inside of our task browser, we're now presented with what this task looks like, and if we're happy with the look and feel of this, we can just insert this into the worksheet with minimum content. So once inserted, you can now have a student just interact with this. They would just type in f of x is equal to something, set x of 0, and then just click the buttons in order to have Maple step through a problem and generate results for them. So here you can very quickly generate a tangent line, and as well as computing details such as slope and intersect and so on. At last, you can also create a graph, and basically gives you kind of a shell that a student can work within. So here's another quick example that I inserted here. Here's the implicit differentiation of a function. So here a student would enter in an expression. They would then enter in x, y, and step through the problem using the execute buttons here. So next let's move on and talk about the math apps that we have available inside of our product. So Maple features just under 200 different math apps for various subjects. And each one of these math apps is basically a small contained environment that interactively demonstrates a wide variety of mathematical and scientific concepts. So let's move on. Let's just show a very quick one here. I'll scroll down through these, and I think we'll pick the approximating the volume of a sphere using cylinders app. Right click on this. This opens up a math app worksheet inside of Maple. So similar to what you saw with our Explore command or the task environment, students can just come in and interact with this by just entering values or engaging with interactive components. So here you can see I'm just sliding out the values, and now the student can very quickly and easily see how if we change the number of cylinders used in creating this sphere, we can actually get closer and closer to the proper volume of the sphere. So there are many other examples. As I mentioned, there are just under 200 different math apps inside the product, and each one of these are really great ways for you to give a student kind of a quick, easy interface to learning a very fundamental concept within mathematics. And everything that I've now shown you, they all build off this idea of being able to have interactive components. So to give you an idea of how a lot of these examples were built, I've just constructed a very, very simple example here using our interactive embedded components. So opening up our components palette here on the left, this presents you with all the different components that we have available. So now you can do is insert a dial, a plot, and a text, and very quickly and easily have these three interact with one another. And this is really handy. If you have a student or you have a peer that somebody wants to come in and use Maple, but they may not have that programming knowledge that you have of Maple, you can very quickly and easily just send them a worksheet that has a dial and have them turn the dial in order to get some type of visual feedback or some type of information directly from your demonstration. To give you an idea of how this was constructed, I'll just open up the Edit Value Changed action of this dial button and put this down here so we can see where all this information is going. So what this does is it uses a couple lines of Maple code. So first I am finding the value of the dial, and that's using the do command. So do %, dial 1. Then we set an equation. So here's the equation. Equation is equal to 1 minus a, so the value of our dial, times cos of a over 2 times theta. We then set our plot value using do %, plot 1 is equal to a plot interface of this equation, as well as the math container by do %, math container 17 is equal to equation. So you can kind of very quickly and easily see here that the value is coming from this dial here and being sent over to these two other components here. So if you're looking for more examples on how to build these, I definitely recommend, again, going back to the Maple portal, and there's the dynamic applications. It's the 9th part of the Maple tutorial, and it walks you through using the Explore Assistant, as well as creating some of these very quick and easy interactive component-based examples. But before we move on to the last part of our talk today, I wanted to quickly also show you a new and exciting innovation for Maple 17, and that's how to insert a video directly into your Maple worksheet. So now I've gone over to our component palette and I've just clicked on the video player. And by clicking that, I quickly and easily insert a video component into our worksheet. Now if we right click on this component, we can now set it to view a window or a video. So I'm just going to browse to our Maple 17 data, videos directory, and we'll open up our Mobius video, press OK, and we've now inserted a video directly into our interface that you can then use inside of an application if you wanted to demonstrate if you want to show a student an example and you want to have them walk through a problem. You can show a video of how you would demonstrate that problem. You can also use it as a kind of a tutorial where you yourself show a video of walking through a concept or so on. It's really unlimited what you can do with these videos inside of your Maple worksheet. So to close, I'd like to mention a few more resources that are available to you. One of which is our built-in Maple Cloud. And the Maple Cloud allows you to exchange documents with users all around the world, as well as creating your own public or private clouds for, say, your class. If you want to, you can very quickly and easily create your classroom Maple Cloud and then share your documents with your students and only your students. Or if you'd like, you can also create a personal cloud if you want to just lock it down. You can create a personal cloud in order to share only documents with yourself. And this is kind of handy if you're moving from one Maple machine to another Maple machine. You can just go to open up your Maple Cloud and just in order to just retrieve your Maple documents. The Maple Cloud is also the showcase for all of our new Mobius apps. So you can view these by new, popular, and so on. And if I just open up one of these, it'll just open up a new tab. And you may recognize a couple of these math apps. A lot of these math apps are also available within our app guide. But there are also many new math apps being added to this every single day. So let's talk about a couple more web-related resources. So first of which is our Maple Primes user community. And here is, again, a great resource if you're looking to just quickly and easily ask a question from another user, or if you're looking to kind of mine the the newest and latest in Maple coding techniques or applications of Maple. There's a lot of really neat new stuff that happens on Maple Primes every day. Specifically geared for educators, we also have online our Maple Teacher Resource Center. This is found on maplesoft.com/teacher-resource or under the resources menu. And specifically within our teacher resources site is our teaching concepts with Maple. And this features a collection of very short, I think they're all 2 to 3 minute videos on ways that you can apply various concepts to your classroom teaching environment. So if you click on any one of these, say evaluation of a limit, this presents you with an example of one way that you could teach evaluating limits using Maple inside of the classroom. So again, that's the teaching concepts with Maple. It's a collection of great material that I would highly recommend you have a look at, and that's within the Maple Teacher Resource Center. We also have many other examples directly available within our Application Center. This differs slightly from our apps and our Mobius apps in that these applications are often, they're kind of more academic, they're more white paper-ish in nature that you could step through. Say if we open up finance here, financial engineering, it'll give you a specific worksheet that seeks to solve a problem. So here, the first one here, we walk through the Black-Scholes model, and we basically illustrate how this could be solved and worked with inside of Maple. So it may not be interactive in the same way those math apps are, but it would give you kind of that full example on how to use Maple for a specific purpose. Last but not least, we've got our Maple player for the iPad, which is freely downloadable in the App Store on Apple computers, as well as the Maple player. And I'm going to close down everything here for a second in order to open up an instance of the Maple player. Because this Maple player, this is something that we just released a new version of a few weeks ago. And it's really a fundamental game changer for us. It really gives users a new way to explore Maple documents all around the world. So what's different about this new version of our Maple player is that you can now open up any Maple document you'd like directly using the Maple player. So what this means is that if you have a student that you want to send a Maple worksheet to, but they don't necessarily have Maple, you can send them one of your interactive math apps. They can open this up using the Maple player and then interact with it. So here we can go through and we can drag out these values in order to change this mortgage app. You may be wondering, you can also file open. You can open up any of your own interactive math documents directly within the Maple player. But this is really handy, right? That if a student doesn't necessarily have Maple, but you want to share them, you want to share a worksheet, or you want to share an example with them, you can just send them this application and they can open it up directly within the Maple player itself. As you saw before, we have built-in integration here for the Maple Cloud, so you can also use any of the apps that you've potentially shared with your students inside of your Maple Cloud group, as well as posting apps to this cloud yourself. So again, I highly recommend, this is a really, really vital download. If you have any type of interactive applications that you've constructed inside of Maple, download the Maple player, share it with other users, and get that interaction going out there. So with that, that actually closes off the main part of our talk for today. We're going to move on now to